Okay, so welcome back. It's hard to believe this is our session 5. It feels like we just started in September or August. And here we are starting to finish literally for the rest of the year. But that doesn't mean that even between now and the end of June, if you have any questions, again, just send me an email or a text or whatever is easier for you, and be glad to support or send you any materials that you need. But really, we've kind of got 6 weeks of sort of valuable instructional time left. So we still have time to catch some of our students who aren't maybe at that learner outcome level yet. And I'm sure we have a few that still need that time before we really start evaluating or assessing them from a summative perspective of whether or not they've met the learner outcome that we're going to report on. So today I want to go through just a few pieces that we left out to review for May. We did say that we would leave stats until we met again, which would be now. So I'm going to talk about that as well. So we'll look a little bit at statistics and just make sure that everybody's sort of on the same playing field with understanding about that as well. And then we're going to sort of dive into a few activities so that you get a sense of, in the event, and I'm not saying this will be the case for everybody, but in the event that you end up perhaps even bringing in a grade 2 or ending up going in a different grade, that you'll have a sense of how our conversation in fractions in grade 1 would link to some of the potential things that they might do grade 2, grade 3, and so on. Okay, so let's carry on here. We'll start with our land acknowledgement first, and that is we respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant community. So we're not going to go through this page again. It should look familiar. We did this one last time, and we talked about symmetry and all the different places that we can have students observe it and that they could be part of it, and it should be very hands-on. But it also is a great way for us to connect their conversation in fractions about halves. Because if something is symmetrical, the two sides are the same. And so in this case, even if I had a heart and I cut it in half and I had students try and find the matching partner, then they would get that same sense that symmetry and the half are very similar, that I would be looking for the same things. And then what we'll do is unpack this one here at the end of our session.
And in this video,
so we won't go through those again. But when I talk about even looking at 1.1, which we started with in September and we're still constantly revisiting, and that was kind of an important one because that was kind of the head of students understand and interpret quantities to 100. We need them to really master the 100. Because if they're going to go to grade 2 and work to 1,000, if they don't have the 100 mastery, there's no point in talking 200, 300, 400, even worrying about 1,000, because I have no concept of what anything larger than that would be. So really that mastery of 100, and it will definitely get tooled up again as they come into the beginning of grade 2, but they really have to understand those numbers from 0 to 100 on a number line, for example, and how do I maneuver back and forth between them? How well versed am I in being able to find any number that you give me on a number line, whether I have markings on the line or not? So we'll do a little bit of an activity with that as well. And then we also want to make sure that not only can I rotely count for you to 100, but I can start at any point. I can count by ones. I should be able to skip count from any number at any point, by twos, by fives if I need to. I should be able to be versed in going with tens, and so on. So we want to make sure that students see themselves in that. So this slide is one that we did last time too, and we looked at the different kinds of number lines that we could download from Sparklebox that looked at focusing specifically on skip counting by twos or by fives or by tens, like what that might look like, even with the subitizing number on the bottom if it was less than 10. But again, I'll go back to right where we started in September, and that was these subitizing cards are absolutely so important. They give us so much information about the outcomes that you have to cover in grade 1, that using them on a day-by-day basis just gives you so much more feedback about what the students are and are not able to do and what they're able to handle. And even again, if I take the pile of subitizing cards and just randomly divide them into, assuming that you've taken out whatever numbers they shouldn't work with, and the students on their own can turn over 2 cards at the same time. And can they quickly call out which card has the bigger number? Like, can they just say it's a 4, where the other one might be a 2? Can they do that? And just doing it on their own, calling it out, calling it out, calling out. So it's quick and it's an instantaneous kind of, I'm able to see it. I have some tools to understand what 4 bars might be. I might go 2 and 2. I see a 10 frame. I might use 5 and 5. Whatever they're using, whatever their strategy is, can they recognize those fairly quickly? Do they know enough about the rec and recs that a full beat of reds means that there would be 5 of them, and then just adding 2 on would give me 7? So again, we're looking at the addition and subtraction to 20. Can they do that kind of work fairly quickly? So we would do that even with our subitizing cards. Eventually, once they get past just warming up of which number is larger, I turn 2 of them over, and can they add them, right? So what's the sum? We're going to use, I'll put this in the chat box as well for you. One of the other places that I just want to go to, Toy Theater isn't always my favorite for everything, but for a couple of the ones I'm going to share with you today, it is for a couple of reasons, and we'll practice it. So I'll throw this link in the chat box. You want to grab it and then just bring it up on your screen. So subitizing, while you're doing that, subitizing is something that actually children do before they learn numbers. They learn to subitize at age 3 before they actually know the symbolic number 3 or 2 or 1. It makes sense to them to see quantities of numbers in substance of sets as opposed to a quantity that's symbolically represented by a number. So we need to pay attention to that, because if that's really where they start, then we need to always build on that and use that and leverage that. Now, the domino offers us a couple of things. One, I can do the same thing as I do with 2 subitizing cards. What it doesn't do is it doesn't offer me the variety of the subitizing cards of seeing different ways to represent 2 or 3 or 5 or 10, because I'm not seeing anything other than a dot pattern. And that's okay. I mean, for some of the things, if we just want some quick repetitive kinds of work, then I might want to do some of those pieces. So in this case, what I'll point out to you first is how this one works. So every time I hit new, I'll get a new domino. So I can control that, or the student can control that. What number I see on the domino can be controlled here. So if I want to go up to 9 by 9, making the sum of them 18, getting very close to our target of 20, then I might want to leave it there. But if I'm a student who really is still struggling, I can barely get to 6, then maybe I want the standard ones so that I'll never see a number larger than 6 as long as I go through this. So you have some control of what the dominoes would look like. And again, if we have a student who's working below that, I can even limit it to 3 and 4. Right? I can really make these quite manageable as to what the maximum number could be on any one side. So again, let's just say that I'll leave it at 9 for now, but let's just say that one of the pieces I wanted to do was just like you did with the subitizing cards. All the dominoes are face down, or they're playing online like this, or you're projecting this on the screen and you're going down the rows or however you're doing it. But you've got students who are just calling out which side has the biggest number and what is that number. So I would be calling out 5. I'd be calling out 3. I'd be calling out 5. I'd be calling out, in this case, 3 and 3 plus 2 more is 8. And if somebody said 8, I would ask that student to say, how did you get 8? What was it that they did to figure out that this was 8? 8 is correct, but just the number alone doesn't get deep enough for us as teachers to know what was their thinking behind this. So did they see 2 lines on the side, which is a familiar 6, and then they added 2 in? Or did they see 2 lines this way, and that was their 6, and they saw 2 lines this way? How did they figure out what they saw? And I will say to you that no 2 students in your class necessarily will ever see that dot pattern the same. In the same way as if I had asked all of you as adults, how many are on there, and then how did you get it? You will not have the same answer. As adults, we have certain patterns that are already imprinted on our brain, and your brain will go to anything that's familiar that it's seen before and use that information to help you decipher that this was 8. And you will not all see it the same way. Some of you may even just see that the corners here were 3 and 3, and then you got 2 this way. It's important for students to hear how other students got the total so that they recognize that there are different ways of getting that number, which is one of our outcomes, right? When we talk about composing and decomposing numbers, there are multiple ways to show a number, not just one way. And so this is another way for us to meet that outcome by letting them listen to the fact that, hey, you saw corners? I didn't see corners. I've never seen that before. I wouldn't even have thought about that. Janet, question.
So what do you do with a child who looks at you and says, I don't know?
So I would say, what part of this do you know? What do you recognize that is something that you've seen before? And they might only say, well, I know that a straight line is straight. Okay, well, that's great. Do you see another straight line? Yep. So let's unpack. Do you know what 3 and 3 is? What are our doubles? Our double 3. Great. Okay. So then, and then just add on one more, and then, so you're breaking it down for them in the way that you would hope they would break it down.
Okay.
Okay.
All right. Thank you.
Filled in. I always ask, how did you get that? And some of them will say, well, I went 3 and I added 3 and got 6, and I added another 3 and got 9. And some will say, well, I counted the top row. I counted the top row and I got 3. And then I realized that they were all the same. So then I went 3 plus 3 plus 3. And others will say, I saw 6 and then I added on from there. So again, it's that different thinking that they come up with that gives other students a way of realizing, oh, like my way isn't the only way, or I didn't even think of doing it that way. So it gives them another tool in their box as well to do it that way. So dominoes can do a lot, just even adding and recognizing numbers. I could add them together, right? And what would be my total? Again, I can always call out any domino that goes over the number that you want them to go to. Our goal is 20. So if I set them at 9 and 9, I'm not going to go over. There's no way. You remember that you can also buy dominoes that are 12 by 12. So that gives you a 24. And some of your grade 1s are more than able to handle a 12 plus 12. So you might want to get a copy of those. You can buy those at Walmart. They're called Mexican dominoes, and they give you everything up to 12 by 12. So it's a great tool for us to use in this way the same. What if I wanted them to talk to me about comparative language? Like, what if I wanted them to say which number is less than the other number? So maybe what you could do is take a sheet of paper, draw a line down the center just with a ruler, and you can have these pre-done or just use them as a template. And on the left-hand side, you could say smaller. On the right-hand side, you can say larger, or you can say less than, greater than, like however you want them to measure, like you've got to decide. And then because the dominoes here already have a line on them, or any domino has a center, then I can say, I want you to turn over 5 dominoes and I want you to place them on the sheet. So let's say smaller was on the left-hand side. Then when I place this domino, the center line that goes down the center of the paper will match the center of my domino. The 4 will be on this side and the 8 will be on this side. So now I can have every student, they're going to turn over their own dominoes. They're all going to have different combinations, but I can quickly walk around and just see how are they doing, and are they in fact able to tell me in comparatively which is less, which is greater. So they're making that comparative language. I could even ask them, how do you know that 4 is less than this? How do you know that? Well, they could say, I counted, there's 4 dots and there's way more than 4 dots. Good reasoning. What else can you tell me? What else do you know about it? Well, I can see that this one only covers the 4 corners and then there's dots in between. Good reasoning. So again, it's getting them to say, how do you know that you're right? Like, you're right, I get it, but how do you know that? What's your way to check it? So it's just another strategy piece for them to work on. Okay, if I go back to my slide deck here, I'm going to bring up another one. It's also in Toy Theater. And so I'll throw that one in the chat box, or you can probably just find it on the. So this one will bring up the dice. And I could leverage a dice to do almost the same thing as I did with the domino or with the subitizing cards, if that's what I wanted to use. So here what you're looking at is you got a multiple different number of dies that the kids can use. I personally find that the one at the top, the tetrahedron, it's too confusing for the kids. So I tend to stay away from that one. Even with older kids, I stay away from it because they struggle to figure out which side is really facing them. And I would only use the bottom one if I wanted a number that was larger and maybe I want them to count. So I might use the bottom one. I'll just bring that one up. So if I rolled it, I'll just roll one. So as it rolls, I might say to them, whatever number, of course, we started with a 0. What would be the odds? So I might say, can you skip count from that number up from there by 10? Or skip count from 5 from that number? Or skip count by 2 from that number? Because also they're supposed to be able to do all of those activities from any number. So what if I rolled a 40? Can you skip count by 5s? And the next student, we could say, oh, we're at 40. Can you skip count by 2s for me? Can you skip count by 10s for me? So and so. So again, I could use that one, but that's about the extent that I would do with this. I wouldn't do a whole lot more. It's more for the upper grades. The one I really like for grade 1 is the green one. Because when I throw the green one, it has a maximum of 12 on it. And so now if I, first of all, if I just want them to know recognition of number quickly, can they see it? Is it 10? Yeah, they know it's a 10. And for some of our kids, that's still a little bit of a challenge, right, is to recognize the number. But if I change it to 2, then I could do the same activity that I did before. Throw the 2 dice. Which number is larger, which number is smaller, right? And I could have the conversation, or you could say, call out the die that has the larger number. All those activities that we did with subitizing or with the domino could be done here. I could even have them write out, what is the 2-digit number that you could get from rolling these 2? So they could write 34, they could write 43, both are correct, just a 2-digit number. And then whatever number you wrote, I wrote 34, Leah wrote 43. And then I might say, based on the number you wrote, can you now count by ones till you reach whatever goal I tell them, right? So can they just count from that? So I might go 10 more than what it was. So again, the kids are kind of in control of the number that they're choosing or getting. The chances of everybody getting the same number are nil. So I don't really have to worry too much about that. But the kids love it because they think they're in control of what they're doing. And I get to write which 2-digit number I get, not you. You're not giving me a piece of paper. That's fine. I don't care which number you chart. I start with something, right? The only problem you run into is when you get a 2-digit number. So these dies are really helpful when it comes to just calling numbers out again at random. We do have students, and there is actually a syndrome, a mathematical syndrome, where students cannot see numbers. They see dot patterns. They can tell you categorically what the dot pattern is. They can add the dot patterns. They can do everything with a dot pattern in and 10 frames in the same way as a student who sees 34. They would see it as 3 10 frames and a 4. That they can show you, but the minute you show them the number 3-4 symbolically, they don't know what it is. And there is an actual syndrome that prevents students from being able to see that. Now, that syndrome is rare. However, we need to find out whether that's the scenario that students are in. Some students just subitize. That's just what they stop there. That's where they want to halt. So those are the students where I need to say, could you find me a card? Like, let's say I rolled the 4. Could you find me a card in our subitizing deck that reflects that number, right? So let's now see if they know what 4 is. Can they find 4 fingers or 4 vertical bars, or can they find a 4 on a reckon rack or 4 on dots, whatever. But can they find it without me saying it's a 4? Can they find that number? So that we're starting to get them to do that recognition. So that's another piece to this puzzle that we always have to be in tune with as well with the students. So those are 2 really good sites that I find are helpful for just even at this time of the year, you want to do some games, but just to double check who's there. And if they're consistently showing us numbers, if they roll 2 dice and they consistently skip count by 2s, they consistently can come up by 1s, check it off. They've got it. If they've consistently done it, not one-offs, but consistently do that kind of an activity with you, you don't have to wait till June to say, I've mastered it. They've mastered it. They've got it, right? And we can add more to their plate, but we don't have to necessarily wait until June that we make a decision to say that they've got it. You can also get dies that have the 9 frames on them as well. Instead of having the numbers, they'll just show you them in dot patterns. And again, for some students who cannot see the numbers, then having a dice like this available to them is helpful as well. outside of just our regular 6-sided die. The other piece that I wanted to revisit is in session 1, I had shared a number of slide decks with people about subitizing. And they were just a variety of dot patterns that they were already put into PowerPoints for you. You would just put them up on the screen for like 2 seconds, 3 seconds, and then have the kids just close their eyes for a minute and pretend that they can still see what was on the screen. How many dots did they see? Have them write down the number, because now I can practice writing the number. And then we say, how many people, how many did you think you saw? And I say 3 and everybody else says 4. Then we bring them up and we see, let's check. Let's see how many we saw. And then we'll go back to that same conversation. You saw 4. How did you see 4? What was it that you saw that helped you to see that there was 4 when it disappeared? And again, having that math talk. Those slide decks came from a guy by the name of Steve Wyborny. And Steve has kind of dedicated his teaching career to making so much free math for teachers in the classroom. So if you're not familiar with him, I didn't want to leave us this year without showing you this. And also that you can subscribe to his daily emails. What he'll do at the beginning of every week is he will send you a new SD mystery or a new slide deck with dot patterns, whatever you've asked him to send you. But they just come. He's archived them for years. You can go back and grab any of them, like anything that you want to do. So there's lots of places that you can go and get resources. So here's an example. He has 100 subitizing slides. They start small. They're not in traditional order, and they get very big. And now it's we give students a chance to see it, not a whole minute to see it where they would count it. But, we would increase it if there's tons of dots on there, then we might give them 5 seconds to see it. And then what's your best guess? What did you think was up there? And then if you're really close, how did you come up with that? Or if you got the right answer, how did you come up with that? What was it you saw? What was your thinking? What were the patterns that you looked for? So these are available free on this site. And I will put this into the chat box too. And you can also access it when you get the slide deck. All the links will be live. So just put it in the chat if you want to grab his link. And what I want to also just show you is it's not just about subitizing dot patterns. If you go down the left-hand side here, you'll see all the different categories that Steve has already created resources for. And a lot of teachers, I like the SD Mysteries personally, use SD Mysteries or estimation. They use them on a daily basis. So when the kids come in, there's one up on the screen already. And they are done, the SD Mysteries in particular are done in sort of chunks. He does K to 2 is one group, 3 to 5 is another group, and then 6 and older is another group. So the questions that get asked or what I'm looking at in those SD Mysteries is somewhat lower or sort of scaffolded for the age appropriateness. When we were online with COVID, I was the principal of the online school and I had a math club with students every week. And I had one for kindergarten and kindergartens came on and that's what we would do is we would do SD Mysteries. Now I gave them a few perks and helps along the way and I can show you those, but I'm going to go into them just so that you can see it. So there's 170 new ones for this year. All his other ones have been archived and you can access them at any time. There's no shortage. They look like this. We won't do this one, but we will do one. So here's an example of one where I would be looking at that vase and I'd be trying to guess how many spin tops are in there. And then based on my guess, I'm going to be provided with a number of clues that are hidden initially. But every time I unveil a clue, I'm allowed to change my estimate. So kids are not locked in. They can read it and then they come to oh, wow, okay, that's not going to work. My number doesn't fit into that clue anymore. So when we do it with kindergarten or grade 1, what I would do with them is ahead of time, I would give them maybe a number line that had the numbers written out. So let's just say that their number was 27. Okay, that was a number. I might say in one of the clues might say, my number is not smaller than 10. So then we would talk about if it's not smaller than 10, what does that tell us? What could we cross out of all the numbers that are on our list? What could we cross out? So if it's not smaller than 10, well, anything smaller than 10 is gone. So I just cross out 1, 2, 3, 4, 5, 6, 7, 8, 9. All of those numbers are gone. So I do scaffold it a bit for the kindergarten grade 1s. I do not for the grade 2s. And if I have high flyer grade 1s, I don't scaffold it at all either. But I do give them those little bit of tools just to help them. And the reason is because once they get the hang of it, then you probably don't need to do it. But initially, they'll realize that it usually comes down to 2 numbers that you have to choose from. So you might have had your guess. Maybe your guess is one of the numbers and maybe it's right. But there's another one that's left over on your sheet. And maybe that's the right answer. Maybe now you want to change it. So let's just go down. You can go down further and further here. You'll see a whole bunch of them. And this guy always comes up, not sure why. Always just drives me nuts. So we're going to go into the ST Mystery series. I'm just going to grab any one that comes up here. Let's go down to the bottom here. Okay, I'll do one I haven't done today. So you'll see right here, it says grade 1, 2. So let's try one. If you notice in the bottom left-hand corner of my screen, a PowerPoint just came up. It gets downloaded. So everything's done for you. It's not like you have to create it. Oh, this one might be a big one for sure, but that's okay. We'll play it. Okay, so he had them set up for distance learning because he knew that that was the scenario for most of the world. So he had done some of those. So if slides 2 to 7, if ST Mysteries are already working well for you, if you're just getting started, then you might be using some of the other ones. So use slides 8 to 13 if you simply need an embedded chart to write on during the discussion. So he scaffolded it for those who were online. And I need a step-by-step animated chart that eliminates numbers after every clue. So again, I even have a scaffolded approach that would help students see, oh, that number disappeared. Oh, that number disappeared. Oh, that was my number and it just disappeared. Now I might need to change my new approach. Okay, so let's just have a look at one of these. And as an adult, how many pom-poms do you think? What's your best guess of how many are in that vase? So I'll give you a second to look at it and you're probably going to try and count them. And just on a scrap piece of paper, write down what you think it is. Okay, so know that we are allowed to change. So how many? You can change it after each clue and write down your first estimate and then change it if you need to change it. So here's your first clue. The answer is less than 61. So do you need to change your number or is it still safe and still good? The die has 6 sides. The answer includes the digit 6. So that's a helpful hint. It's also helpful terminology. Do they know what a digit is, right? So in my answer, I have the digit 6 and it's a number that's less than 61. The answer does not include the digit 1. So if any of your guesses so far have a 1 in it, now you get to re-guess and you already know a 6 is in it. The answer does not include the digit 3. And the answer does not include the digit 5. So you may or may not have changed your estimates. The red reveal comes up prior to the answer being shown. So there is your answer, 46. Now, these have been, lots of teachers use these as a day by day in the morning. They just use that as a quick warm up. You can use them for estimating as well. He has some in the estimation column where you will get, let's say, just a glass, and the glass is full of a bunch of pom-poms. And so again, you guess, what do you think is the most reasonable estimate of how many pom-poms are in there? And then before we go on right onto anything else, it'll tell you how many pom-poms are in there. Because in the next picture, it shows you a glass half full or approximately half full. So now that you know how many fit when it's exactly par with the top, what would your best estimate be when it's only half full? What would it be when it's mounded over the top, like stuffed in as many as you can on top without them falling off? So those are great estimation questions, and those are very appropriate for grade 1. They can absolutely handle those. So this is a very busy little site, but it's a wonderful site for resources for you. Okay, so in May and June, we're also kind of still working on interpreting and explaining. We're solidifying is really what we're doing, that they can do the interpretation explanation of any quantity that's within 100. They can represent equal sharing or groups within 20. So if I gave you 19 pom-poms and I said, can you equally share these out? The answer would be, no, I can't, because I'll have one left over. But I can talk about how many each person got. That should be equal. So again, it's just a matter of literally just working those. And then if the students know their doubles, we can have that conversation about doubles as well. You already know that 8 and 8 is 16, right? So I can equally share out 16 into 2 groups of 8. We're not looking for multiplication facts or addition division facts. We're just looking for, do they know their doubles? Because that's going to be important. Students interpret and explain the quantities, and then they examine addition and subtraction to 20. So those are all the pieces we've been working on over and over. So now you're basically showing them new games or games to revisit where they are working on and solidifying that. And again, you do not have to wait until June before you come up with oh yeah, they've got it. We can do that at any point in time. So we could also use Cuisenaire rods to create any combination, decompose and compose numbers. I can see if I can equally share out a number, a target number that you gave me. Can I share that out equally? And I could use the double tracks on a DeciTrack to put one group on top and one group on the bottom. And do they both end at the same place? Is that an equal share? Were there any leftovers? So I can do that easily with the DeciTracks and Cuisenaire rods. Okay. When we look at sort of what we're also finishing here, and that is students acquire an understanding of addition and subtraction, but also we're looking at students examine 1/2 as part whole. So we had already talked about fractions in one of our other sessions, and keeping in mind that in grade 1, we don't actually show them anything symbolic in fractions. There's no 1/2. It's all in terms of language and understanding what the language is going to be. So we want them to be able to represent what 1/2 is. Half of an orange, half of an apple, half of a sandwich, right? That they have a concept of that half means that the 2 pieces must be equal. And that's why I started with that review of symmetry. Good place to connect the topic about 1/2. We're going to do a little paper folding activity in a minute. With those strips of paper. So if you came on a little bit late, I asked anyone just to grab a couple of sheets of scrap paper or whatever, normal 8.5 by 11, and cut some strips on the long side, the 11-inch side, the long piece of your paper. Just cut them about 1 inch wide, just off of that paper, because you're going to use those as your holes in just a second. And then what we're going to do is in grade 1, when it comes to statistics, the students need to be able to ask a good statistical question. And so the question for me to you is, what constitutes a statistical question? Like right now, we often have with elementary school children, especially grade 1, kindergarten, even grade 2, you ask, does anyone have a question? And they put their hand up. And as soon as you call on them, they don't actually have a question. They want to share something with you. They want to tell you a story. They want to tell you, did you know? Which isn't a question, right? Really, per se. They've kind of missed the point of what a question is. But statistically, those questions are a little bit different. There are some parameters and rules around them. So we will watch a very short, two short videos, one specifically for grade 1, one that revisits what we do in grade 1, but then also kind of ties it into the dot graphs that we do, the dot plots, and just expands a little bit on that so that we're all in primary talking the same language around statistics. That's kind of an important piece, especially the question part. So again, when we talk about sets, we're talking about looking at, can I find a half? The set could be a number of 10 items. Can you divide those into halves? Could I divide 9 into equal halves, 8 into equal halves? I could do that with Cuisenaire rods. Here's the 8 rod. Can you find 2 rods of the same color to put above it so that there's no holes, no overlaps? And yes, I can find 2 4s. Can I find one for the 7 rod? No, I can't. Can I find one for the 6 rod? So there's a way for us to show them the halves that we're talking about. But we'll also do a paper fold for that as well. When I talk about addition of quantities, I'm working to 20. I should be able to add all kinds of different combinations to get to 20. So maybe an activity could be, I want you to show me 16, and we're going to use money. So can you show me 16? And in the first opportunity, we're going to say, show me 16 any way you want. It's your choice. You go through your money bag, you find me 16 cents any way you want. And they might show me a dime and 6 pennies. They might count out 16 pennies if they have enough. They might use nickels and dime and whatever, like whatever their ability is at that point, but they can choose whatever they want. The next time around, we're going to do it again, but this time I'm going to say, but one of your numbers to start with is 10. So show me 10. They might show you 10 pennies. They might show you 2 nickels. They might show you a dime. And now from there, can you fill in what the rest would look like to make 16? So I'm composing 16. Or if I want to go into doubles, I can say, I'd like you to show me 16, but I'm giving you the first number, and the first number is 8. So they'll either show you 8 and then find a mirror image of it, create another set of it, or they can even just take individual 8 coins and show that they skip counted by 2s, whatever they want. We didn't say how the 8 had to be put together, but I want to compose 16 from 8. How would you do with Cuisenaire rods, right? So 16, I could say, show me 16 any way you want. Well, they could take all 1s if they wanted to. They can take reds and whites and yellows and any combination as long as it ends at 16. Bravo, you got it. But then when I put that same restriction on it, the first one is a 10. That means you're putting an orange rod in, and now I'm building from the orange rod to get to 16. Or if I have an 8, I could put an 8 at the top, and I can show what would the double have to be. I can either add on to the 8 or I can do it below. And I know that the double 8 is 16. So what am I going to show you for 8? And it could be all different. Could be an 8 rod. I mean, whatever they decide. We didn't tell them how they had to put it together. So the 2 videos that are on here is just a quick reminder of comparative language to 20 and ordering numbers. So if I gave them a bag full of number cards, so remember when we did the number lines and we had the numbers to 1 to 100, the little square numbers, I could have them reach in. Let's say I only had the bag that was 1 to 20. I could have them reach in and pull out 3 numbers at random, whatever they are, it doesn't matter. So let's say I pulled a 7, a 14, and a 19. So I might say to them, which is the least? Show me the least and put it down on your table on the left-hand side. Show me the greatest number, put it down on the right-hand side. Show me where the other number belongs, obviously in between. So do they have that comparative language? And how do they know that the one in between fits there? What would they say to you if you said, how did you know this was between the 7 and the 15 or whatever number I drew? So how did you know that? So they might say, well, I could count from the lowest number to this number, so I know it's there. And then I can keep counting and I get to the bigger number. Good rationale. They might say, if I put it on a number line, here's the number, it's between these 2. Great, good thinking. So what is their thinking? Let's find out what they used to figure out the comparative language. And then the same thing would be true. Let's just put all the numbers from 1 to 100 or 0 to 100 in there, have them pull 3 numbers out. And can they do the comparative language conversation? Can they put them in some kind of order? Let's not always have it from smallest to largest. In this case, you're seeing largest to smallest. And so that they have both directions that they can do. You could even say, here is my middle number, it's 61. Can you skip count from your middle number to your highest number by 2? Can you skip count from your middle number to your last number by 5? Can you skip count, and so on? I could even ask, could I skip count from my lowest number here to my middle number? Yes. By what? 2. Can you skip count by 5? No, not enough numbers. By 10? No, not enough numbers. That's the kind of thinking we want to hear from them, not just assume that they know it. Make them say it to us so that we hear them say it. So again, I could use my dominoes and I could ask them to arrange, they could have their own little bag of dominoes and have them face down. Again, they're in control here. That gives them some power, and they do like that. Tell them to put their dominoes in groups of 2, one over top of the other. And now we could ask them, if this was on a piece of paper, maybe you even already have traced out how big a domino is. They actually put them onto the pattern where you have the empty domino square. And beside it, they're going to write, what is the number of the domino that they just showed up? What's the 2-digit number? So this one would be 45. This one would be 63. Okay, we're not going to get anything bigger than a 66, so we don't have to worry about that unless you're using larger dominoes. So in this case, what are the 2 numbers? And now then I could say, which number of the 2 that you wrote down is the larger number? Can you write me 3 numbers that are in between those 2 numbers that you just wrote down? So every child will have their own, they're in control. Usually what they do is they ask, well, how do I know what order to put? Like, should I put the small number first and then the big number? And we just say, we don't care. You decide, you make the decision. Because I don't care if it's 54 or if it's 45, it really doesn't matter to me. I'm going to give them instructions one way or the other, and it could be numbers in between. It could be, can you skip count by 2 from that number? Can you skip count by 5 from that number? Can you count by 1s to the next 10, like whatever that turns out to be? So all those different pieces, just from using a simple domino, lets me get to all those outcomes over and over and over and over again. Same thing with the subitizing cards. I could lay them out in groups and pairs. What number do I see? I see 35. What number do I see? I see 38. Okay, which number is larger? 38. Can you skip count from your lowest number to your largest number by 5? 35 to 38? No, I can't. Why not? Because there's not 5 numbers in between. Can you skip count by 2s? 35 to 38. Yeah, I could do 1, 37, and then I would run out. That's the kind of thinking, again, to let them muddle with it and just sort of work their way through. Number lines, obviously, we still want to work on those, and especially with the testing that you've been doing for COVID loss and for learning loss. Number lines are a huge part of that. So they need to see their numbers on a number line. Can I find the 2 numbers that I wrote down here or here? Can you find those on a number line and just have them available? Where would you put them? And then can you show me a number that's in between? If they got stalled on that, let's put them on a number line. Can you show me a number in between? So giving them a way to bail themselves out without giving them the answer, or saying, how many numbers are in between? What could you count to? Let them kind of work their way through that so that they have a strategy in place when they have to do it by themselves. So here's our number cards that we talked about. So let's talk a little bit about stats, because I do want to spend some time here. In grade 1, students investigate and represent data. So what that means is, investigate means that they would ask questions. So I'm going to design a question, that's a statistical question, and we're going to go collect our data, and then we're going to represent our data somehow. Now, they don't actually go into interpreting what their results were. That comes into grade 2. But I'm going to say to you, I'd be pretty hard pressed as a teacher to do a dot pattern on a graph and not say, what did we notice? You know, that it kind of is a no-brainer that would follow in here. So they're not doing any kind of written interpretation or any deep analysis, but it would be very reasonable to say, you know, if our question was, what are the top 3 favorite foods or fruits? Let's do that one, fruits in our class. And that could be your model that you use to show them how this works. And then they have to come up with a new question. So we put up, everybody in the class gets to say what their top 3 favorite fruits are. And then we just put tally marks on, we collect the data, we show them how we collect the data. And then we start plotting this, right? And we see which fruit comes up over and over and over again. Which one is our more popular one? I'd be hard pressed not to have that conversation with them, even though they're not interpreting, because it's the logical answer to your question. But that is the extent that they would do in grade 1. So what I'd like to do now is just play both of these. The first one is very short. It's less than a minute or a minute long. It talks about what is a good statistical question. How do I know a statistical question from just an ordinary question, and they are quite different. So just to make sure.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about understanding statistical variability. A statistical question is one that results in multiple and varying numerical answers, rather than just one single answer. Let's look at these questions and see if they are statistical questions. What grade did Hannah get on her math test? Is this a statistical question, yes or no? No, it is not, because there is only one answer. We need many different number answers. Next question, who earned a better grade, Frank or Grant? Is this a statistical question? No, it is not, because it is not a number answer. And finally, what grades did everyone in second period math earn on the test? Is this a statistical question? Yes. It is yes, because we get a lot of different number answers. So there you go, statistical questions and variability. Thanks.
So some of our students have trouble with questions, just coming up with a question. But just because I get a one number answer doesn't make it a good statistical question, as they just talked about. So let's look at just a review of that, looking at what a dot plot is, because that's what we do in grade 1. We do dot plots. That's the graph when you unpack the knowledge and the skills and procedures. But it will talk a little bit about the range. It'll even talk about a peak. So what if we asked about the 3 fruits, right? And we said, look at this, bananas are way up there compared to anything else. That would be the peak that she's going to talk about. And we can use that terminology with the students so that they start to see that, wow, there's so many more people like bananas over any other fruit or whatever it turns out to be.
Hey guys, it's Kaylee. This lesson is an introduction to statistics where we'll cover statistical questions and dot plots. Let's get started. You've probably heard the word statistics, or its abbreviation stats, before. Statistics help us answer questions like, who has won the most times in your video game? Or how many times and how fast did I run on different days this week? Statistics is the science of collecting, organizing, analyzing, and interpreting data. In statistics, data is very, very important. But how do we collect data? There are a few ways. We can run an experiment or have a survey. But in both of these ways of collecting data, there is one main thing in common. We have to ask a question. When we ask a question to collect data, it needs to be a statistical question. A statistical question is one where you expect to get a variety or a lot of different answers. Which of these do you think is a statistical question? How tall are basketball players? What time did you wake up this morning? How much money do people typically spend on cars? Do you play soccer? Right, it's these two here. But how do we know that those are the statistical questions? It's because when we ask them, they will provide us with a variety of different answers that we will use as data. Whereas these two here can only give us one answer. Be careful not to confuse statistical questions with survey questions. If we have a statistical question, how tall are basketball players? We will have to take a survey of many different basketball players and ask a survey question like, how tall are you? You can think of a statistical question as one where you would have to ask a lot of different people the same survey question to collect data. But once we have our data, like how tall are basketball players, we need to organize it. See, right now it's just listed between two brackets, but the numbers are all out of order. The best way to organize your numerical data is from least to greatest. So we take our least point, 65, and put it in the beginning, and we take our highest value, 82, and put it at the end. Then we can analyze and interpret it. One way we do that in statistics is to display data on a dot plot. A dot plot is a type of graph where each piece of data is displayed as a dot above a number line. We stack the dots on top of each other over the number to show the frequency of the data. The total number of dots on the plot is equal to the total number of values in our data set. By displaying our data in a dot plot, we can analyze our data more easily. A dot plot shows us the spread or the range of our data. In our case, the heights of basketball players range from 65 inches to 82 inches. A dot plot can also show us the shape of our data. Ours is asymmetrical. That means there's a different number of dots on either side of the center point. Symmetrical dot plots will either be bell-shaped or U-shaped. But either way, the number of dots is the same on either side of the center point for symmetrical data. In a dot plot, we can easily see if we have a peak in our data. A peak means a data point that occurs with the most frequency or the most often than other data values. Do you see a peak in our dot plot? Yeah. In our data, we see a peak over 81 inches. So we can say that a basketball player with a height of 81 inches occurs most often. A dot plot will also tell us if there is a cluster. A cluster is when there are a lot of data points within a small interval or a small range. Do you see a cluster in our dot plot? Yeah, that's right. We have a cluster in our data between 78 inches and 82 inches. So we can say most basketball players have a height between 78 inches and 82 inches. Dot plots are also an easy way to visualize any outliers. An outlier is when a data point is either much greater or much less than the rest of the data. Usually there's a big gap between the rest of the data and an outlier. Do you see any gaps and outliers in our data? Yeah, we have an outlier data point over here at 65 inches. So for our data, we could say it's not very common or likely for a basketball player to have a height of 65 inches. And now that we've analyzed our data in our dot plot, we can interpret our data. This means coming up with a general answer to our statistical question. Remember, our question was, how tall are basketball players? And looking at our plot, we can say most basketball players are around 80 inches. Nice job learning about statistical questions and dot plots. Now practice what you've learned by doing the online games and activities.
Okay, so that gives you a good sense. Again, it's just the common terminology that centers around what is a good statistical question. And then just giving them some...
Welcome to Moo Math and Science. In this video...
Hey guys,
Fortunately, those always come on. So again, we could even show them, here's an example of a favorite sport. Maybe you want to ask that same question in our class. What's our favorite sport? And just see what the results are for the students and let them plot that, and then we can see that on a graph. again, you'd probably still want to zero in on, we see that although it's not big difference, we see that hockey came up most often in this particular example. Or here I see that dogs are the most favorite pet. Or maybe I show them this and what question would they ask? What would be a good statistical question if we showed this example on the board for students so that they get practice at it, so that they learn that it's not just a yes or no that we're looking for and the differences between that. Okay, so the last thing I kind of want to do today is to look at when we model a half. So if you can grab one of those pieces of paper that you cut today, the strips. So I've just got a strip, cut it on the long side of the paper. And what I want to do is a couple of things. One, we're going to go one step further than grade 1, but we're also going to look at the half piece that we want. So I have one piece of paper, and I'm going to say that this strip is called my whole. Okay, whatever it is, it doesn't matter. I don't need to measure it. It's just called, this is my whole. So how would you show me half of your whole? And we would get the kids to do this. They would do that. They do it with us. So if I folded it in half, I see that I've got 2 equal pieces. So one of your outcomes is, how do students show or verify that 2 halves are the same size, same pieces? Well, this is one way. I took my whole, I folded it into 2, and when I got that, I got 2 identical pieces, one over top of another. So now I can see that the 2 halves are the same. Right? I could do that with a fruit. I could do that with a candy bar, blah, 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 like all of those. All right, what I'd like you to do, because we're going to go one step further, I want you to take it, open it up, and put 1/2, like actually write the fraction, 1/2 and 1/2 on yours, and then just put it down in front of you on your table, and grab another piece of paper. Okay, same whole, right? Because we just cut it off an 8.5 by 11 piece of paper, so the whole hasn't changed. But this time I would like you to fold this piece of paper into quarters. So let's think about what that would be. If I folded it in half, I now have 2 pieces that are exactly the same. If I fold it one more time, my 2 should give me 4. So when I open it up, I should see 4 equal pieces. And if you folded fairly accurately, they all look the same. So for our purposes, let's put 1/4, 1/4, 1/4 on them. Just again, so that you can see it, and put it right underneath your 1/2. Okay, so let's try the one that's up on the screen. You just did quarters. I'd like you to take your next strip, same whole, and turn it into 8s. So think of how you did your quarters. What more would you do to create an 8? So I'll give you a second just to do that, and then I'll do mine. So again, if I fold it in half, there's my 2s. If I fold it in half again, that gives me 4. If I fold the 4 in half, that would give me, each quarter is divided into 2 again, so that would be 8. So I should have a very small piece. When I open it up, they should all look the same if I've been relatively good about folding them. And I should see 8 equal pieces. So I want you to write 1/8 on each one of those, and then put it below your quarters. Anybody get lost along the way, just chime in or turn on your screen and I can give you a hand with it. So those even numbers are pretty easy to do, right? We just fold. But what I'm getting to, and we're going to do one more, and it should become really apparent, but what are we noticing as we're laying these all out underneath each other? My first one had 2 pieces. My second one had 4 pieces. My third one had 8 pieces. So in grade 2, one of their outcomes or one of their skills and procedures that they need to be able to model is that the student understands that there's an inverse relationship between the size of the denominator and the size of the pieces, meaning the bigger the denominator, when I had 8 in my denominator or 8 pieces that I asked you to fold your paper in, the bigger the number, the smaller the pieces. The smaller the number, 1/2, the bigger the pieces were. This is a really deep concept for kids, and they don't get that very easily. They need to see it. Adults need to see it. They need to understand what that means, because often when you say to a student, is 1/2 bigger or smaller than 1/4? They'll think in terms of whole numbers. 4 is bigger than 2. So 1/4 must be bigger than 1/2. So again, we would take them through the activity that will allow them to see this. Let's do one more. And if you look on the screen, I'd like you to take that strip this time and turn it into tenths. Okay, I'd like to have 10 equal pieces. 10 is like our dimes, right? We can do a dime for $1. Our dollar is right here. So when I fold it in half, and if my original is going to have to be tenths, in other words, 10 pieces, when I fold it in half, what is the size of my half now? If we're shooting for 10 and we folded it in half, what is the size of each of these halves? How many are sitting in there? Anybody want to chime in? So this is 10 was the whole one. When I fold it in half, I end up with 5. Right? Now, think about this for a second. What happens if I fold the 5 in half? Will I get a whole number? No, I won't. I'm going to get 2.5. Well, they're not dealing in decimals, so that's not going to work. Odd numbers cause us grief because I can't just fold them and fold them and fold them because I'm not getting whole pieces. So what the problem is I need to change my 5 to an even number. I can't add a piece on, but I could make it smaller and change it to a 4. So as an adult, forget about the kids right now. I want you to eyeball your piece that you folded in half. This is 5 long. About where do you think 1/5 is? I'm going to say where my finger is. I'm going to say that's about 1/5. I'm going to fold it in. I'll find out how accurate I am in a minute, but I'm going to just take a guess, best guess, eyeball it. How big do you think 1/5 would be? And I just folded it in. So here's my piece that I folded, and I'm just holding it down. So the piece that's left over now isn't 5 long anymore. I took 1 away. It's 4 long. Well, what do I know about 4 long? Well, 4 long, 4 I can fold in half. That gives me 2. And I can fold it in half one more time to get to the 1. So now I have my little square. So in theory, when you open this up, you should have 10 pieces. If you had a really good guess about how big a 5th was, your guess piece should be almost identical to the other ones. If it's not, it's no big deal. But I end up with 10 pieces. So anytime we have an odd number, I need to get rid of the odd number and put it to an even. But this is another one where I can go 1/10, 1/10, 1/10, 1/10. And again, I can say to students, well, what are you noticing? We got more pieces this time. We have 10 pieces. What happened to the size of the pieces? What if I asked you to make 16 pieces, right? What would that look like? So they're getting this, the gist that the more I add in for the pieces I want to see, the smaller they start to become. So that students get the visual of that. Junior high students don't get this yet. this is our chance to kind of pick up on those pieces and work our way through and catch some of those kids. So in the slide deck, when you go in the folder, I did put the one for the tenths in here to show you. So I folded it in half. The 10 became a 5. 5 doesn't work. So I took a guess at how big 1/5 might be, and I folded it over. And then when I hold that fold in my hand, fold it again, open it up, I can see that I end up with 10 pieces. And I can turn my guess over and see if it actually fits on top of the other ones or not. That's another way for, as an adult, I can see how good an estimator I am. So this is a way for them to find anything. Students will say to you then, even the youngest ones, they'll say, give us another one. I might say, okay, I'd like to see 1/7.
Oh,
So
wow.
1/7 means 7's an odd number, got to change it to an even, right? So I change it to an even. Now it becomes 6. When you fold the 6 in half, that becomes 3, odd number. Again, how much would 1/3 be? Fold it back, just keep folding back. Got an even number 2, fold it in half, I get the 1. Open it up, I should have 7 pieces, and you will have 7 pieces. So there is no number that they can't do this with once they get the hang of it. And I allow students to even have them on their desk so that they can do that kind of comparison. Now, the one last piece I want you to take is go back to your half, the very first one that you started with. If you have another piece of paper still, make another half, like just fold it in half. So here's my new one. I'm going to fold it in half. But all I want you to do now is take that half and rip it on your fold line. I just want to use one piece of it. So I ripped it off, and here's the half that I had originally. Instead of calling this my half, I'm going to call this my whole. So here was your original one that you folded in half with the 2 pieces. I'm going to say, this is my new whole. Can you show me a half? So when I take my new whole and fold it in half, I'll say to students, okay, so what is each one of these 2 pieces? Oh, it's a half, because you took it and folded it. But how can that be? How can this be a half and this be a half? How can each one of these 2 sides be a half? So that is a concept in grade 1 that they need to start to wrestle with, is what the whole is determines is how big the half is. Half represents a portion of something. The size of it could be different, but what it represents is always going to be a half, 2 equal pieces. The 2 equal pieces don't have to be the same size, as we can see here. The fold lines don't line up, and I don't see the same size, but they both represent a half. So then we could say, if I cut a watermelon in half, I would have 2 equal pieces. If I cut an orange in half, I would have 2 equal pieces. But the orange is definitely not as big as the watermelon. They're both a half of what we started with, but they don't have to be the same size to be a half. So that's something that they need to really see over and over and over again. That's a concept that doesn't just dive into the brain and stay there and, oh yeah, I got it. That's not an easy piece for them. Okay, you could do the same with a piece of string. Once I've done that paper folding with them, what if I just gave them a piece of yarn? Doesn't matter, string, yarn, anything, doesn't even matter how long it is. And they grab a number out of that bag of 100. What if I grab 78? I say, okay, 78 is the end of your string or your yarn. So little clothes peg, put the 78 on, or piece of tape. So here's 0, here's 78. And I want you to draw another number out. Okay, and let's assume that they can't get larger than 78. So let's say I drew 32. So if this is 0 and this is 78, where will you put 32? Well, it'll be somewhere down here. But could you be a little bit better at estimating where it might go? What have we learned about paper folding of a half? So if I take that and fold it in half, that will give me a value that's halfway to 78. I could even use my number line if I wanted to at that point. And now I can estimate about where 32 is going to go. It's going to be close to the middle, but not right beside it, for sure not. So this is a way that we can start to get them to think about those numbers to 100. How could I use my paper folding of a half to help me figure out where numbers would go where I don't have a ruler? I just have a piece of string. That's all I have. So I can change the value at the end at any time. Start with something simple, maybe start with 20. 20 folded in half gives me 10 in the middle. And I drew 7. Where would you put, if 10 was here, where would you put the 7? Probably not down here and probably not sitting right on top of the middle. But, you know, 3/4 of the way there are reasonable. We're not looking for perfection here. So this is the way that I can translate that same notion of halves and my work that I have to do about numbers to 100 and put it on a number line. And to finish things off, and before I do that, I just wanted to go to Janet's comment about, sadly, I have kids that still don't know their left and right. So how would we do, let's say, even the comparison of the dominoes on the left side of the page and the right side of the page, smaller on the left, larger on the right. What would be ways that we could still have them engage in the math side of it and get around that left and right?
Oh my.
Any thoughts?
Sorry.
Lots of teachers where the kids don't know their left and rights. What do you do? I've seen it when I walk into classrooms.
I use my name tag, because it has left and right on it.
Good.
So I give them
Yeah.
that resource, and then they have that to look at.
Perfect. Right on.
We sometimes put left on the top left side, or L for left and R for right.
Yep. So
on the
on
right
that,
side.
yeah, that's right. And that sheet that has a line going down, I would put that on there, left and right. And I've seen teachers too, where they take erasable markers and we write L on our left hand and R on our right hand so that we can see them, right? They just have them on there as they're working with them, depending on what they're doing in the
I
whole.
also make my kids make L's. So which one is the right way?
Excellent.
I
Right.
do that too.
Yep. That's perfect. That's exactly what you need. So yeah, they can still do the math. It's kind of like when I go to thinking of teachers who say, they don't know their math facts. They don't even know how to multiply. So how am I supposed to teach them how to divide? And I said, if we're talking about, do they know their math facts? The answer would be maybe no. But if we're talking about how do I divide, divide is a process. So I shouldn't be prohibited from learning the process of division without having my math facts. And I can teach any child at any grade who doesn't know how any math facts. I can teach them multiplying by 1. That's an easy number. Any child gets that one. Multiplying by 10 is an easy number because I add a 0. Multiplying by 100 is easy number. I add 2 zeros. They get that pattern really quickly. If they can do 1, 10, 100, and whatever you need them to go to, you can teach them to divide anything more accurately probably than some kids who are trying to guess what they're going to put at the top. So again, there's always another way to go at a procedure as opposed to they don't know this yet, so therefore we won't go there because they're not strong enough in that. So we have to make sure that we still give them the tools. And your ideas are perfect, you guys. I mean, that's exactly what everybody would pretty much do. So, okay, let's just finish up then. The resources that I want to leave you with. We won't go through all of these, but there's a couple here that I just want to point out to you that are stronger than the others. The NZ math, if you remember when we did Cuisenaire rods without any numbers on them, we went to New Zealand, we used the NZ Cuisenaire rods. What we didn't explore at the time was what else was available to you as teachers. So in the NZ math, although I get the manipulatives there, they also have a bunch of teaching materials and they're all done for the teachers already. You have full access to them and they're editable. So I don't necessarily have to use them all. So a lot of these are tasks. And you have options to use bits and pieces of them, all of them, but they're already pre-done for you. So again, it's a resource that you can go to. Good thing to, to check for assessment when I'm looking to see where students are at. The other one is the Ontario Math. I have shown you this one before, but I just wanted to make sure that everybody knew. At the top, you have the old strand conversation. Let's go to number. And what you'll see is 1 to grade 8 in Ontario. Now, some of their 1 is now our kindergarten, but the majority of their 1 and 2 is our 1. So what you do is you simply read the descriptor of what is behind each box. If this is where I want to go, so for example, this one here says, compare and order whole numbers to and including 50. Okay, I don't want 50 for grade 1, I want 100. But that's a good starting point if you need to differentiate. In grade 2, they go to 200, so I'm going to find 100 in there as well. Pick one, doesn't matter. Whatever I click on, you will get a whole bunch more activities that are already scaffolded for that learning outcome. So they're already ready for you to use and do whatever the activity is that you want them to work on. So here's covering up to 100. You just have to pick and choose. But go to the descriptor boxes first to decide what it is that you actually want to use, and then you'll kind of narrow it down from there. The last one I want to highlight here is the LT squared. Again, I've shown you this one too, but this is a powerful site. I really like it because it is for birth, not kindergarten, birth to grade 3. So it really unpacks the learning trajectory that children are going to use as they are going through their math learning. So how this might work for me as a teacher, there's lots of games, there's lots of resources, but over here, if you go to Explore, Explore brings up trajectories. And by this trajectory, what I mean is, let's say I just wanted to know about counting. Where do kids start when they learn counting? Well, they learn from just the basic foundations of saying things after an adult. Then they go into chanting, they go into reciting. Any one of these that you click on, if you see where a student is stopping and that's kind of where they park themselves, any one of these that you click on has work that you can do with them behind the scenes. And it covers every possible aspect of our curriculum. So you kind of have a great resource here now, or even at the beginning of the year if I want to use them just to see where students are at as a pre-assessment. So that gives you lots of possibilities that you can access just through this one site. And it really is only up to grade 3. It does not go beyond that. So it is total primary focus. So those are 3 sites that I would spend some time looking at. And again, just tooling up, adding into your lesson plans that you created throughout the year. Oh, this one would work well when we did this, or I would want to keep this, or maybe I want to do this at the end of the year because this is something that they're ready for now. So that gives you an opportunity to kind of grab some of those. So even though our sessions are over, you don't hesitate to reach out at any time if there's something you need. If you need some assessment questions, or you're just trying to see where kids are at, or you need some more of something, please don't hesitate to reach out. I will be glad to send you whatever I have. Again, these will be posted into your Moving Forward folder, so you can access everything that we've done today, including some things that I haven't shared with you are also in the folder, and the slide deck will be there as well. So I look forward to seeing you, hopefully again. I will not be doing the K-3 series again the way we did it now. We are doing 4 to 6, but I will be doing sessions for K-3 starting probably in August. I'll do one in August for sure, but now it's a matter of adding to what we've already done. Now that we've kind of gone one trip through the new curriculum, what else can I start to add into my lesson plans as I go through? So I will do those kinds of sessions so you can watch out for those. And then the next one will be science. So we're unfolding science. Science actually already started. So if we're not coming to your schools to do science with you, then you might want to check out the CARC website. For the K-3, we've already got April 11th was the start of it. So session 1 for all of the teachers has already started. You can get in at any time. And then we're going to be unpacking 2 organizing ideas for you in science. The first one will be living systems, and the second one will be matter. We did learn from the first round that order should not change. It actually works well for the concepts that you have to link together. But you also need to be aware that the science curriculum changed significantly from the first round. So if you were with us the first round and you wanted to use some of the resources, we will leave them up, but you will have to go in and now match them. So the second round that we're going to do will build in computing science and scientific method for you, but it will be based on the new curriculum document. And those outcomes, like I said, have changed significantly. So just be cautious of that if you're using them or were using them, that you're not using the old one. That'll be the important piece. So thanks, everyone. If I don't see you before then, I appreciate your coming on and hope that your rest of year goes well. Leah, if you have a second, can you stay on? If you're rushed, that's fine. I understand. But thank you, everyone, and best wishes to you for the rest of your year.